All right, everybody, this is section 21, Law of Sines, day 2. So we're going to look at a few other ways to solve non-right triangles, but this today we're going to focus in on solving for angle measurements. So I know we solved for some angles yesterday where we could just subtract from 180, but sometimes we can use law of sines. We're going to use it to find not just side lengths, but also angle measurements. So look at a little bit different kind of format for this one. So let's take a look at the information that you know. You are given an angle measurement here, angle B, and you have little b and little a. So remember our law of sines, we have ratios of sides to sine of the angle opposite. So I'll just have our law of sines over here handy. So you can have these ratios, this proportion, like we said, in any order that you'd like. So you can have the sine of the angle on the top and then the side lengths on the bottom, or vice versa. But the idea is that the side and the angle across the sizes are proportional. The biggest angle always across from the longest leg. The smallest angle always across from the shortest leg, in the middle. So what I'm going to do is go ahead and try to just draw a rough sketch here just so we have an idea of what we're talking about here for this picture. So we have an angle B. That's 105. So I'm going to try to make a little bit of an accurate sketch here. So 105. And we'll just go ahead and draw the rest of that triangle. So we know little b is 23. So remember how we label our triangles, that the angle is always crossed from the side length that has the same letter, so uppercase and lowercase. Then we're going to have our angle A and our angle C, right? So it doesn't really matter for right now for the picture for how we're going to label these. So I'll just go ahead and call this over here A. So we'll do A, B, and then C. So it doesn't really matter for sure, but we just have to make sure we get our side lengths in the right spot. So little a is 14. That means across the triangle from A is 14. So when we say solve the triangle, remember that means find all the pieces you don't know. So first of all, let's identify what we don't know. It looks like they didn't give us the side across from angle C, so we don't know little c. It doesn't look like they gave us angle A, so I don't know angle A, and I sure don't know angle C. So I have really 3 pieces of information I need to find. Angle A, angle C, and then little c, or side C. So I have 3 pieces to try to get. Now, the way law of sines works is we need to know a side and an angle across from it to be able to solve. So right now, using what we have, I know side B and I know angle B. So I'm going to be able to use law of sines to help me solve for missing pieces because I have that side and angle across from it. The other piece that I have is side A, which means if I look at this part of the law of sines, I know angle B, I know side B, and I know side A. So what I'd actually be solving for in this case is angle A. That's my only missing piece. So we're using what we know and what we're trying to find. So let's go ahead and set up that proportion. So side A, 14, is to the sine of angle A, as the side B, we know 23 is to the sine of angle B, which is 105. So we have our proportion. If you remember from yesterday, how do we solve the proportion? Well, we do our cross product. So we would do 14 times the sine of 105, and that's going to be equal to sine of A times 23. So 14 times the sine of 105 degrees is equal to 23 times the sine of A. All right, so what we're trying to do, remember, is solve for angle A. So we want to get that angle by itself. So the first thing I would do is divide by that 23. So just like we were doing yesterday when we were solving, so cross multiply and divide. That will undo our multiply by 23, and that's going to leave you with sine of A. So we have this 14 times the sine of 105 degrees divided by 23, which we're going to do on our calculator in just a minute. Now, the whole idea is that we don't want sine of A, right? We just want angle A. We just want that angle measurement. So if you remember, we have to undo that operation. We need to undo sine. And this is where our inverse comes in. So we've talked about this idea of opposite operation before. What we're going to do on each side is take the inverse sine. And remember, inverse on your calculator is the sign with that little -1. That's not an exponent. That means undo or inverse operation. So we're going to take the inverse sine on each side of the equation. So I'm going to undo, just like if you have squaring, you'd square root each side. If you had multiplication, you divide. We always do the opposite. So I'm going to do the inverse sine on each side. Now, why does this work? Well, wherever you do a function and then it's inverse, they undo each other. So we're going to be solving for angle A. And now here's what we're going to need to type into our calculator. So let's go ahead and grab your calculator. We can do it all in one step, or we can do it in pieces. So I'm going to kind of show you a couple different options. So I'll start with doing everything on the inside first and then taking the inverse. So just so we're not doing too much at once. So we'll have our, first of all, 14 sine of 105. So we have 14 times the sine of 105 degrees. Don't forget, got to finish off the parenthesis. That's a huge goof people make. And if you don't finish off the parenthesis, you're not actually dividing what you think you are. So then divided by the 23. And let's see what we get for that. That's the number on the inside. I wouldn't write that down. You don't need to. That's a decimal number. We want to take now the inverse sign of that value. So we do second sine of our answer. Finish off my parenthesis, and we're going to go ahead and round to the nearest whole number just to make our life easy. So this is 36 degrees. So angle A would be 36 degrees. So I've solved for that first piece. So angle A, 36 degrees. We're just going to round to the nearest whole. Now, another way that you could do that, if you want to type it all at once, and this is kind of what I do, I start off with the inverse sign right away, and then I do 14 times the sine of 105. Don't forget to finish off that parenthesis, divided by 23. And we can get that all at once. So if you want to do it all in one step, that's great. But we use inverse, right, to undo what's been done to that side of the equation. So this is 36 degrees. All right, now let's take a look at what you have then. Don't you know two angles of the triangle already now? So if we know two angles, how do we find the third? Well, we just subtract from, what are the three angles in a triangle add up to? 180 degrees. So we're going to subtract from 180. So to find angle C, I'm going to do 180 minus those other two angles. So the 36 and the 105. So let's go ahead and just do a quick calculation there to find our angle C. So 180 minus 36 plus 105. So go ahead, type that in, see what you get. All right, and hopefully somebody has come up with 39 degrees. So we got 39 degrees on the other angle. So again, we just rounded the nearest whole. We use that rounded number, and that's okay. So now we have everything except for little c. So how do we find little c? Well, we can go back and use law of sines. It's the only part that we are missing. So we still know everything about b. We can still use that in our proportion. We know angle C now, so we should be able to solve for it. So what I'm going to be using is this part of the proportion. So this second part, I know little b, I know angle b, I know angle C. So now what I'm going to be solving for is side C. So I'm going to go ahead and set up that proportion. So I'm going to clear myself some room here so we can still see the picture. All right, so let's set up that proportion. So I have little b, 23, is to the sine of 105 degrees as little c, don't know it, that's what we're looking for, is to the sine of angle C, which is 39 degrees. We had filled that in before. All right, so let's see if we can go through and solve this. So how do we solve a proportion again? Well, we're going to cross multiply and divide just like we did before. But this time it's going to be just like what we did yesterday. So we have 23 times the sine of 39 degrees equals little c times the sine of 105 degrees. Now in this case, to get the c by itself, I need to undo what's been multiplied with it. So I'm going to divide both sides by the sine of 105. And I can get that solution. So let's go ahead and see what that would be here. So we've got 23 times the sine of 39 degrees. And then divided by the sine, don't forget to finish off that parenthesis, right? 105. And we get 14.98. So if we want to round to the nearest whole number just to make life easy, looks like that would be about 15. So let's talk about reasonableness here. So if we have that as 15, I'm going to go ahead and fill that into the picture. Let's talk reasonableness. Our biggest side is across from the biggest angle. Makes sense. The next largest side should be the what's across from the 39. That's the next biggest angle. That's the 15. 36 is across from the side that's 14. So what the smallest angle, smallest side. So it makes sense. It's reasonable. So when we're looking at using law of sines, we can find either sides or angles. When we use an angle, we use inverse, right? We have to undo. But all the rest of that process is going to be exactly the same. All right, so let's take a look at just one last example of that. Try that, and then we'll do our area question. So let's take a look and see what we have. We're going to round to the nearest tenth for this one. We have an angle A, a side A, and a side C. So I'm going to go ahead and set up a picture here so we can talk about it. So we have an angle A that's 70 degrees. Remember, across from that would be side A. And then whichever one you want to call C, it doesn't really matter. We can decide what makes sense for what we're going to do here. So it really doesn't matter. So I'll just do ABC. So our angle C we don't know, but we know side C. So across the triangle from C is our 26. Okay, so solve the triangle means, again, find the pieces you don't know. Well, I don't know angle B or angle C, so I would need to find those two. And the side that I don't know is little b, the one that's across from angle B. So I need little b as well. Okay, so take a look and think about what we know. I know everything about A. So when I set up my proportion for law of sines, I have 25 is to the sine of 70 as, okay, now what's the only thing we can really solve for? Well, the only other piece of information I have is side C. So side C is to the sine of angle C. I have no other option. There's nothing else I can solve for because I don't know anything about B at all. So then I can go ahead and do what I did in the last one, cross multiply and divide. So 26 times the sine of 70 would be equal to 25 times the sine of C. Cross products are equal. I need to undo what's been done. I'm trying to solve for C. So the first thing I'm going to do is divide by the 25. So that will undo that multiplying by 25. So then I have sine of C is equal to this 26 times the sine of 70 degrees divided by 25. Now again, I'm not going to worry about getting that number until I just do it on my calculator. I need to figure out how to find C. Well, I have to undo sine, so I do its inverse. So on each side, I'm going to take the inverse sine, and I can solve. So I'm going to take the inverse sine on each side of the equation. Again, that's doing the opposite operation. It's no different than taking the square root on each side if you have squaring. Because what happens then if you do a function and its inverse, they undo each other. You'd be left with C, and then over here, it's whatever that value is. So I'm going to do it all at once again. So I'm going to do inverse sine, and then I have 26 times the sine of 70 degrees, finish off that parenthesis, divided by 25. Go ahead and try typing that in yourself. Make sure you try it. Don't just assume it's going to work for you, and then enter. So for this one, I think I might just go ahead and round to the nearest whole number again for this one instead of tenths, just to make our life easier. So 77.7, rounding to the nearest whole number, that would be 78 degrees, just to make this a little bit easier. All right, so we just figured out what angle C is. Fantastic. So this is 78 degrees. So once you know two of the angles in your triangle, so I know 78 and 70, I can find my angle B then. Remember what the three angles in a triangle add up to. How much? 180. So I can subtract off those two other angles. So go ahead and subtract off the 70 and the 78. See what you get for angle B. And that should be 32 degrees. So double check and make sure that that checks out for you. So 32 degrees. Now we have all of our angle measurements. What's fabulous about that is now we can find our little b, right? We have everything we need to know to find angle or side B. So I'm going to go ahead and move this. So again, we can still see our picture. So we're going to start our proportion the same way. We're going to use law of sines. We still know everything about A. Ooh, and by the way, in the last one and this one as well, I'm not going to use the 78 and the 26, even though I know both of them now. Anybody know why? Think about why you maybe wouldn't want to use especially the 78. That's a rounded number, right? So it's not going to be as accurate as using the given information, which was the A's. So always go back to your given information when you're going to solve. You have a much more accurate answer. So now we can set up for little b is to the sine of 32 degrees, and we can solve for little b. So we're going to cross multiply. So 25 times the sine of 32 equals little b times the sine of 70. Now in this one, if we're solving for a side length, we don't need to worry about inverse. We don't have to undo sine. We just have little b, so we're just going to divide by sine of 70, undo what's been multiplied with it by dividing, and then we're just going to type that in. So we have little b is going to be equal to whatever that value is. So we have 25 times the sine of 32. Again, finish off that parenthesis, and then divided by the sine of 70, which turns out to be, looks like rounding to the nearest whole, looks like 14. All right, so let's double check our reasonableness here and see how accurate this is. For 14, I'll fill that in on this side, so that's 14. So it's across from the smallest angle, so it should be the shortest side. And is it? Absolutely. And then 25, That's across from the 70. That's the angle that's in the middle. 78 is the biggest angle, and it's across from the longest side. So I know my answers are reasonable. Always check for that. Okay, our last one that we're going to do is we're going to talk about area. So remember, we can find area of the triangle using that formula we did yesterday. So if you can flip back in your notes, fill in that area formula and see what we have so we can figure out what parts that we need to solve that. So what was the area formula we talked about yesterday? Well, it's equal to 1/2. You have a side times another side times the sine of the angle that's in between. So we need two legs and an angle in between. So you need side, angle, side. In order to be able to use that area formula, those are the three parts that you need. Okay, so I want you to take a look at the triangle that we have right now. Looks like I have two angles and only one side. So I for sure need another side. Like there's no way around this. I'm going to have to find another side if I want to use this formula, the 1/2 AB sine of C. I know everything about this pair though. I know the side across from it and the angle. So I'm going to put some letters on this just so we can have something that's reasonable to do. So I'm going to go ahead and put in an A and a B and a C. We could really do this however we want, but just so we have some labels. So I really know like little b then, side B. I know angle C. What could we find really easily? What would be a piece of information we could find quickly? Well, if we already know two angles in the triangle, I could find the other angle, couldn't I? Could find angle A. That would just be taking the two angles I know and subtract that from 180 degrees. So let's try that and see what that accomplishes for us. If I can figure out that other angle A, so we can go ahead and subtract that. Looks like that would be 65 degrees. I know all the angle measurements, but I still need another side, right? No matter what, I'm going to have to find another side. But I can now, with law of sines, calculate any side that I want. So let's take a peek and see what, if I follow this exact formula, what I already know. So do I know angle C? Yep, I sure do. That's 22 degrees. Do I know little b? Absolutely. That's the 78 inches. So what I'm missing in the side angle side is this side right here, which is across from A, so I'm missing little a. So if you just think about, always kind of think about the picture. I need a side, the angle in between, and the side. So the two sides are the legs that make up that angle. I'm missing A. But now that I know angle A, I can find it. I can use law of sines. So little a is to the sine of 65, which is angle A, as, let's use the one we know everything about, little b, 78, is to the sine of angle B. And I can actually find that missing piece. So then we can use that area formula. So little a times the sine of 93 degrees would be equal to 78 times the sine of 65 degrees. And we can go ahead and solve for little a. So I'm going to divide both sides by the sine of 93 degrees. And I can get that other little piece that I need. So little a, if we do our cross multiply divide, I'll go ahead and let you just pause and see if you can type that in. See what you come up with. I believe I got 71, and it would be in inches. So we're using units on this one. So we have 71 inches. So once I have that other side, then I can go back and actually use the area formula. So we're using what we know about law of sines to help us solve. All right, so let's go back to that area formula then. 1/2 A times B times the sine of C. And then we can just multiply that together. So the area would be 1/2 times little a, which is 71, times little b, which is 78, times the sine of the angle in between, which is our 22 degrees. You just need a side angle side. Hey, in real life, you know that the triangles aren't going to be labeled. We put the labels on there to make it easy for us. So we're putting in the labels so we can look at it, but it's just side angle side. So two sides and the angle in between. All right, so we have a 0.5 times a 71. Oops, not plus. No, not divide. Oh my goodness. Times 78 times the sine of 22 degrees. And let's see what we get. Looks like 1,000, if we round to the nearest whole, 37. So the area would be 1,037. And what would the units be? If it's inches times inches, that would be square inches. So we can get a really good idea of what that is. We don't even have to calculate a height. We can just use that area formula. So law of sines, super handy. We can use it to find angle measurements by doing inverses. And we can use it to find area once we know that we can find side lengths or angles. We just need a side angle side. So really great applications for law of sines.